start your week 5 learning with Miss Jones. Today we're going to talk about stars and galaxies and wrap up our unit on astronomy. So, stay tuned. Let's define what a star is. It's a body of gases that gives off a tremendous amount of radiant energy in the form of light and heat. Now, stars differ in size, density, mass, and composition. Now, the color of a star depends on its surface temperature. The hottest stars are blue, and their average surface temperature is 35,000 Kelvin. Cool stars are red, with an average surface temperature of 3,000 Kelvin. And our big, awesome, bright sun is yellow, and the average surface temperature there is 5,500 Kelvin. I don't know about you, but all of our stars look like the same color, except for the sun. It does look pretty yellow. When we talk about distance to stars, we use a term called light year, and that's the distance light can travel in 1 year. The sun may seem like the closest star, but just keep in mind, it literally takes 8 minutes for the sun's light to reach Earth. The closest other star system is Alpha Centauri. That's at 4.3 light years away. That's a long time to see any changes in Alpha Centauri. 4.3 light years, wow. I also want you to keep in mind what the speed of light is. It's approximately 300 billion meters a second. In miles per hour, that's 6.706 e to the 8th. That's a lot of zeros. I don't think anything travels faster than the speed of light. It takes 4 years for a star's light in Alpha Centauri to reach us, which means a star could be burned out, but we wouldn't realize that until 4 years later, after it's already burned out. So we had astronomers who created a diagram so we can plot the surface temperature and absolute magnitude of each star. It's called the HR diagram, after Hertzsprung and Russell, the astronomers who came up with it. So on the diagram we have main sequence stars. Those are most of our stars. They range from cool, dim red stars to hot, bright blue stars. Examples of that are the sun and many visible stars in our night sky. Yes, the sun is definitely a star. We also have supergiants on the HR diagram. These are cool, bright, large stars, like 100 times bigger than the sun. A cool star can only be bright if it's large because it needs a lot of surface area to give off a lot of light. We also have white dwarfs. Those are hot, dim, small stars. These can only occur if they're small, like those the size of Earth. That makes you think, dwarf stars, size of Earth? Earth really isn't that big, is it? Now, astronomers have discovered what we call galaxies. Those are large-scale groups of stars held together by gravity. We don't know an exact number, but astronomers guesstimate there are 50 billion to 1 trillion galaxies out there. To infinity and beyond! We are located here in the Milky Way galaxy. Now, there are different types of galaxies. The Milky Way galaxy is a spiral galaxy. A spiral galaxy is a bright center of stars with arms spiraling out. The sun is one of the arms in our spiral. This is 3/4 of all the galaxies they've been able to discover and see. Then there are elliptical-shaped galaxies. The elliptical shape ranges from spherical to oblong. There are no arms in elliptical-shaped galaxies. And of course, the ones that like to be different are called irregular galaxies. These irregular galaxies have small, faint stars that spread out evenly with no pattern. Last week, we talked about the evolution of the sun, and eventually the sun will become a red giant. And again, that's a very large, cool, bright star. It starts when hydrogen is used up, and the star cools and outer layers expand. The size is 10 times bigger than that of our sun. And as we mentioned before, this is the next stage of our sun, but nothing to worry about for billions of years. Eventually it becomes a white dwarf. That's a small, hot, dim star, and that is entered when helium runs out. The outer gases are lost, only the core is going to remain. Ever heard of a supernova before? Do they still have supernovas and quasars at East Corner Middle School? But novas take place as a white dwarf cools. It can explode, releasing energy, gas, and dust. This causes the star to become 100 times brighter than it was before. A supernova is a star that blows apart with a tremendous explosion. Now, supernovas only occur in very massive stars with iron cores. Back in 1054, almost 1,000 years ago, Chinese astronomers saw one so bright it could be seen for 3 weeks in the daylight. Can you even imagine seeing something like that now? To me, one of the coolest things in science are black holes, mostly because we have no idea what they are. But black holes occur if the star is so massive that it collapses, like a supernova, that it even crushes the core. It's a hole in space with gravity so great that not even light can escape it. I know I keep mentioning Interstellar, but if you watched it, you'd be like, whoa, okay, black holes, all this stuff, this and that. It'd be, yeah, go for it. Last but not least, of course, we have to cover the Big Bang Theory. Now keep in mind, this is the most widely accepted theory of how the universe was formed. But theories are not facts. This is just what astronomers think. They think that all matter and energy was concentrated in a very small volume. Then a large explosion or a big bang occurred, pushing the matter and energy outwards. gravity began to have an effect on it, and then matter condensed out, forming galaxies. They also think this took place 13.8 billion years ago, which is when I say, was anybody alive 13.8 billion years ago? So what I'm saying is we don't really know what happened. This could be a logical explanation. And there are also tons of scientists that do not agree on the timeline of when Earth and the galaxies and everything else originated. None of that bothers me though, because we're here now. So, who cares? It's mostly for the people who want an explanation for everything. So, take it as you want. Anyways guys, this wraps up Virtual Week 5 of Learning with Miss Jones. I hope you've enjoyed our small little unit on astronomy. If you guys have any questions or concerns, please feel free to let me know. Till next time guys.